Hi, everyone. Thank you for joining us. We have Tommy Paff here today conducting a Campbell Fittings Crimpnology training. If you have any questions during the webinar, please use the question feature. We'll go over all of your questions and comments during the wrap-up section at the end. So without further ado, I'll pass it over to Tommy.
Thanks, Courtney. Thanks everybody for taking time out of your day. I'm excited to get this session over to you, and I hope you continue joining the other webinars. We've been seeing a good success with them, and I'm pretty excited about the engagement we're getting from you. So I appreciate all the time that you're spending with us during coronavirus. So hopefully soon enough we'll be out of this house arrest. So let's get to it. All right, look at you guys, thrilled to be here. So kind of play a joke into this because crimpnology, I mean, it's a wide topic to cover. Today we're going to be doing the nuts and bolts of it and really dive into the hose assembly process. But seeing all the attendees that have signed up, I mean, we've got the veterans of the industry, we've got some newer people, some people in between, we've got assembly people, we've got sales people, customer service. So I really have strived to cover, crimpnology in a sense that's going to help everybody that's involved here today. So that's what we're after. The main agenda: evolution of crimpnology, how it came to be what it is today, how it continues to progress, the actual building of the hose systems, not hose assemblies. We turn them into hose systems. We'll get into more of that later. And then selling on the benefits of the performance and really harping in on safety here. Looks like we got max number of attendees. All right, here we go. But first, a history lesson. I don't know if you've ever heard of this beautiful man, Trevor Klutz, but we actually talk about him all the time. Sorry, I just got a text. Can't be looking at my phone. Anyway, so we've talked about him in trainings. I don't know if you've been to our Crimpnology 101. Strongly encourage you to join us. But we quote this man all the time. I think today is the day that we pay him some homage. So who is Trevor Klutz? Well, Wikipedia tells us, great source. He's a prolific British author on the topic of chemical engineering safety. But he's credited with introducing the concept of inherent safety. An inherently safer design is one that avoids hazards instead of controlling them, particularly by reducing the amount of hazardous material and hazardous operations in the plant. Really why I bring this up is because it plays into all of our pitches on crimpnology and everything that we do at Campbell. Trevor Klutz helps us play to our strengths with this inherent safety idea, and everything we discuss today is going to be based around this guy. So I wanted to give you a little history lesson on him. Campbell Crimpnology, the safest systems in the industry. So here we go. Like I said before, we've got a wide range of audience here, so I've really prepared this to cover as much as I can. So I really don't think it's too hard to get 2 takeaways that you can use right away after this webinar. We'll have some engaging polls to keep you on your toes, but as we go through this, just try and take 1, but probably 2 takeaways that you can get from this, and then I'll see it as a success. So here's the story that we always tell. So we got the fitting manufacturers back in the day just pumping out fittings. We got the hose manufacturers just pumping out hose, and nobody was talking to each other. So what we did was merge that gap. And sorry guys, I keep getting pop-ups on my screen with the attendee stuff. Sorry, let me backtrack. So we had the fitting manufacturers not talking to anybody, hose manufacturers, and then you guys, the distributor, were stuck in the middle, kind of vetting out both sides, figuring out who was quote unquote quality. So really trial and error, not a real system. When you think of the hydraulic side of things, you got hydraulic hoses, you got the same manufacturer of the fitting, the coupling, the way to put it together, the hose, the same spec. It's all kind of top-down integrated. In industrial, it's far from that. So when we came up with Crimpnology, that was the ideology behind it that really drove us to where we are today in completing a whole entire system, an integrated system. And so this visual kind of helps you understand the merging of that. You know, and we'll get into it where competition has caught up a little bit today with the same idea, but we by far have selling points that we need you to drive to the end user to communicate why you are different for following this process. So again, here's like the Merriam-Webster definition of Crimpnology. Refers to the technology, engineering, and extensive testing Campbell employs to produce the safest hose systems in the industry. And we reiterate it over and over and over again, but we test the heck out of this stuff. You know, the system is proven. You just have to communicate that down to the end user and hopefully not get commoditized. And that's what we're going to help you out with today. And I really, truly believe, even though people are now a little bit more privy to crimped industrial hose over some other assembly procedures, you got to take it that next step. And the more that you know about the process of putting the hose together and the reasoning behind it and the testing behind it and proving the performance out, the better chance of success you'll have with your customer. Here's a great picture, really just showing you the nuts and bolts of it. But you got your shank, you know, attaching into the hose. You got your Farrell interlocking groove. Now we obviously make them without the Ferrule interlocking groove as well for sleeves. And that's going to be for lower pressure and actually going to be in some more of our webinars later today and later this week. You have your combination nipple and your Crimpnology nipple. It's all based off stamp data, and that's how you're going to decide what you choose. But when we get into this today, we're going to show you how the hose is the variable in this experiment, if you will. So we have the constants. We know what our sleeve or ferrule is going to be. We know what our fitting is going to be. We don't know what the hose is going to be. And that's why Crimpnology is so important, because we don't rely on compression percentage or some other kind of calculations. It's a pretty fine science to figure out how you're going to put this hose together. And we are more than confident that it's going to work. And then we take it the next step to show your customer that it does work with all the testing. We could thank some of the people in the audience for sending in their wedding photos today. So appreciate you guys doing that for me for this slide. But I really like the guy in the top left there with the mullet. I think you should burn that image into your brain here. Really, I'm a visual learner, so you're kind of stepping inside the mind of Tommy Papp here. The best way to remember stuff is through pictures, and I need to burn this into your head to remember Crimpnology. Think of these weird pictures, because it's the marriage between the hose, the coupling, and the attachment method. It's one system. We can't be mixing and matching. We can't be doing, you know, fly by the seat of your pants there. You can't be making up crimp specs. Just follow our system. Trust that we've put it together, and we've got a great little union here. Crimpnology, 20+ years of research, performance testing with ASTM D380 standards. That's the standards that we're hydrostatically testing our hoses to, and the RMA safety factor of 3, 4, 5, and 10 times. Safety factor, 3 to 1 for like some water applications. The bulk of the business is going to be 4 to 1, and then you get to 10 to 1 for steam. But really, we're living in the 4 to 1 safety factor realm. So all of our products, every single one of the products you see in our catalog, have been tested on hoses with Crimpnology to perform to a 4 to 1 safety factor, and we attribute our pressure rating based off of that. The crimp specs are pre-calculated and provided for every hose, regardless of manufacturer. A really good question that you get all the time is, hey, you know, can we test this thing out on this such and such hose? Sure, we can, if there's a sales process behind it. If we're going to take this to a customer or write it into a spec, we are more than happy to test these things out for you, kind of do a proof test. But the beauty of Crimpnology is, like I said before, we have the constants of the ferrule and sleeve and the fitting. If we take into account the hose wall average, which I'm going to dive into deeper here coming up, the hose wall average, and use our crimp specs, if you're within tolerance, we are standing behind this assembly as a system and rating it 4-to-1, 3-to-1, whatever the application calls for. But generally speaking, we're doing 4-to-1. So they're all lab tested, field certified. Published pressure ratings, not recommendations. We are the only fitting manufacturer with performance rated hose systems supported by published test results. This is a key ingredient to your sales process. We are publishing this data. We're not just saying, here's our specs, it'll work. You can take it to the next step, which is more important now than ever when this stuff has gotten commoditized. Your customer is just going to lump you in with the other distributor trying to sell the same thing, and you're going to be able to prove it out and say, hey, look, this is not just my word saying that this is a quality product. I am letting you know that this is the exact thing that I'm going to get you. So why is this so important? We have provided you a proven system. No more guesswork. You don't have to, like back in the day, that slide with the 2 chess pieces on the opposite sides there. You don't have to figure out for yourself. You're not fending for yourself to figure out what product that you want, what product is quality. We have the system here for you. It's measurable, it's repeatable, and we know it performs. Time for a poll. Got to keep you all on your toes here. We got 3 polls today, so don't tune me out. This is an easy one for just engagement purposes. Get you all used to using the poll. Get you clicking around. Some people believe that they will get that picture out of their head. I got to hammer home the marriage of the hose and the fitting a little better then. We'll let this go for a couple more seconds. Like I said, this is just a fun one to get you used to it. Going to close it down. 87% voted. All right. The rest are asleep. All right. 57% say yes. 43%. I'm sorry, 57% say no. Good deal. Fun stuff. All right, let's get into it. So, the 4 essential elements to a properly crimped hose system. You got the Crimpnology shank with that 360-degree Farrell interlocking groove, and you got the not exactly there on the right. I mean, I see Farrell interlocking grooves out there, usually kind of a harsh bump coming out. I'm not slinging mud on anybody else's. I'm sure that they work, but all of our stuff is all, again, proven out. There's a reason behind it. You don't have to guess. So that Farrell interlocking groove is that true Crimpnology shank, but then the next is the appropriate serration. So you can have these serrations on the standard shank as well, which is also meant to be crimped with a sleeve. But max number of serrations, you got the retention bump there at the end. If you see on the middle picture and the horizontal green there, the retention bump is important for sealing. So if you have a sharp serration there at the end of your shank, that's where most hose failures are, at the end of the collar. And so when that hose is wiggling around, it's going to kink, it's going to cut into the hose. You're either going to seep media into your application, or it's just going to wear down that hose, kind of like how you wear down a power cord or a charging cord. It's going to fray at the end, and you're going to have issues. So that retention bump is good for sealing protection, and it's also great for helping with hose kinks and issues of that nature. Then you got the old style shank to the right there, the 2 bump, that's designed for just bands. However, I do know that some people out there will crimp sleeves on there, but just know that you're only getting the retention of 1 or 2 serrations versus the max amount. So putting a sleeve on there is maybe a prettier way to do it, but there's no system behind it. The retention's not going to be great, and you know, might as well just band it at that point. And then kind of the evolution of a somewhat of a crimped shank there. Again, these are going to look similar in some extent, but that's why we really drive home the fourth element, which will be coming up in a minute, of the process and what we're going to get into today. But the last thing here is the matching of the shanks. I mean, some of these pictures, the one on the right is the same manufacturer, it just doesn't match up. But really what I'm striving to get across here is the fact that you can't mix and match. You can't grab my Farrell or sleeve, put it on somebody else's fitting, and just hope that it works based off of a manipulated crimp spec. The same issue that we talked about, you know, with that retention bump, this is just an accentuated circumstance here on the bottom right. That shank is going to cut way further into the hose than it needs to, and you're going to see a premature failure there. Whereas ours are matched up, you know, one system, one manufacturer, and you're good to go. A little closer view. No, Kembe Mutombo. Not showing you who it is, covering it, but also don't do this, right? There's a bigger picture. Don't touch that that side there into the hose. It's going to cut in. Going to have big issues. Nice and matched up. Ferrule interlocking groove. Just a much better system. But here's where it's all at. The detailed assembly procedure with the proven performance results. Just a little snapshot over there to the right. When we crimp our hose today, I show actually a larger version of these engineer reports. I want to take a moment to dive in on those and how to read them, how they're going to be useful for you. And the cool thing is I actually matched it up where the measurements that we take, the crimp specs that we will work through, will be reflected on the report that I chose. So you'll see kind of from beginning to end how this all works out together. So let's see how it's done. But first, let's make sure you're with me. So everything we do is based around safety and innovation. Thank you, Trevor Klutz. This is a proven system. It's necessary for assembly, but it's great as a selling tool. Time for another poll. All right. Hope you're listening about Trevor Klutz. Ooh, we got a couple safety first people. That's me paying homage to all the teachers that threw in that tricky multiple choice question that sounded kind of like the answer but wasn't. Learn from the nuns. All right, we're getting close to capacity voted. Good work. The majority of you said inherent safety. Safety first, not a bad guess. It's all the same idea. We're working towards safety. So how do I show these poll results? I think we did. Sorry, bear with me, guys. It's my first time on here. Oh, there we go. It's showing. Cool. Thanks, Chris. All right, here we go. Now we're getting into the actual process of crimping hoses. So, like I said before, it's all about the hose wall average. I don't want to hear about just taking OD, measuring tape, just getting the outside. That's good for checking your final crimp, as we'll get into. But really, if you've ever seen a hose be manufactured or you understand the process of how an industrial hose is made, it's way different than a hydraulic hose. So they're layering rubber on top of each other, and it causes wide variations in the hose wall thickness, undulations of it. So you could have let's say you have a 10-foot piece of hose. You can have shorter, but let's say you have a 10-foot piece of hose. Side A may have a thicker hose wall than side B. So you can't very well set up your crimper, plug and go on the same crimp spec all day, because even that one hose it's either going to be over crimped on one end or under crimped on the other. So you have to measure each side of the hose, and you're taking hose wall into account, and then you just use the chart. It's as simple as that. And then again, to reiterate it, I'm just going to keep pushing through with this. We test, we test, we test. 4-to-1 safety factor. That hose is failing before our fitting ejects. You know, we're publishing the data. All the pressure ratings you see have all of this legwork behind them. So I implore you to understand this. Obviously, as an assembly person, know it well, do it, practice it. I can come out, do it with you. But as a salesperson or even customer service, being able to speak to this stuff is still extremely important to differentiate. So here's a page that kind of does step by step. I'm not going to just straight up read it. I'll just point out some of the main things, but you obviously want to cut that hose squarely. If there's a helical wire, you got to bend that in there. And then you take your 3 hose wall measurements, which we're going to dive into deeper with all this. Assemble. One note is sometimes these fittings, and this plays to the fact that that hose wall can change, but sometimes you notice a fitting will slip in, sometimes you got to hammer it in, sometimes you need to lube it up. Do not use Crisco. Crisco is not going to dry. It's going to be easy in, easy out. We recommend using some soap and water, but if you need to go and get like a P80 or something like that, that works as well. Just do not use Crisco because it's you're just asking for a failure. And then you crimp it and verify the crimp with the tolerance of 10 thousandths final OD, and away you go. So here we go. So you would go to the table of contents. Like I said, today we're going to match it up with an engineering report, so you can see, you know, this come to fruition, and no, I'm not just lying. So we're going to go with a Campbell Cobra, a stainless steel Campbell Cobra today. So A, B, C, D, E, F, this all matches up with our catalog. So you can, you know, refer to that if you don't know exactly what product it is that we're talking about, or you can look and read and see, you know, you got Campbell Cobra, standard Cobra, but this all correlates with our catalog. The most common mistake that might happen here is the Campbell Cobra versus standard Cobra. If you want to think about it this way, Campbell Cobra has that Crimpnology Farrell interlocking groove, much like the products do from section B. Standard Cobra does not have a Farrell interlocking groove. It's made for a sleeve, much like the products from section A. Not one is better or worse than the other. It's just based off the stamp data and what pressure it is that you need to get to. So we would select section C, and today we're crimping a 3-inch hose. So you've got your hose IDs here at the top. You got 2-inch, 2.5-inch, 3-inch, and highlighted in green. If you forgot what page you were on, or you're second guessing yourself as you're putting this thing together, you check the top. Look, we're working with a Farrell, we're working with a Campbell Cobra, and then it tells you the type of materials it is that you're going to be handling for these crimp specs. So we dive in, just a blown up column of 3-inch here. So this page might be a little tricky looking if you've never seen this before. If you're well versed with this, just bear with me. I'm gonna, you know, go through the basics here. So you got your hose wall average in column 1. This is the most important thing. So you take your 3 measurements of that hose wall, you average them out. So in the engineering report that I was referring to, up here in the top right, I'm gonna use my cursor, here's your hose wall averages. So we measured 0.302, 0.295, 0.319, average them together, you got 0.305. And this was nice and clean. As you can see, we have a crimp, you know, a hose wall average crimp spec directly for 0.305. But let's just say you did a 0.300. Well, you're going to go to the closest average. You don't, it's not like a rule of thumb of higher or lower, just the closer one. So you would go to a 0.297 in that instance. But today we got 0.305. And then the next column over, column 2, you got your Farrell select. F for Farrell, X is a placeholder for the material. So you got a plated steel or a stainless steel. and then 300, 344 is going to be your hose size and the nominal size. So today it's a FSS 300, 344, but let's say you're going to your shelves and Tom, I don't have an FPS or an FSS 300, 344. What do I do? Well, we did leave range in where you can bump yourself up to an FSS 300, 348, that next size up. But the key to note in doing that is you remain crimping to the crimp spec that you measured to. So you measured to 0.305, your crimp spec in column 3 is 3.651. Even if you use the FSS 300, 348, you crimp to the 3.651. You don't bump up that crimp spec because it's all about measuring that hose wall average, and that's how we know to tell the machine to compress into the proper size. That's just a side note there. So, and then on the far right in millimeters is going to be your die size. So your dies are all in millimeters, and it's the actually when you shut your crimper down all the way so it's completely closed, it's going to be the measurement, the diameter across of that final crimp. So that 92.7 is the same number in meters as the crimp spec 3.651. However, since the dies are all in millimeters, that's how you're going to select them. So I hope you're all with me here. But the die select is going to be a 92 millimeter die or smaller. So to that notion of when it's all the way crimped, that's the measurement. That's why you can't pick, say, a 93 die, because that's not going to crimp down far enough, because when they're all the way shut, it's actually bigger than the crimp spec that we're looking to get to. So my rule of thumb, all of that math behind it is follow my cursor. Here's my die select, finger up the page. I select my die. Anything that I find that is smaller than that 92.7 is going to be my die. So our crimp spec 3.651, it's got to be the final crimp plus or minus 10 thousandths, 0.010. So that means that you got 3.641 to 3.661 in your range of leeway. So you're really just looking at that second decimal number, that 41 and 61. So we got 51. You got to be within those numbers there. This is what you're going to be looking at on most of the touchscreen crimpers. Just wanted to quick show you, for practicality purposes. It's obviously a little difficult not being there in person, but we're looking at the top left and the bottom right. The top left is going to be your crimp spec, so you plug that in, 0.305, and the bottom right is going to be the die select. That top right number is going to actually be, I'm going to go back, this number, because like I said, it's just this crimp spec number in millimeters. But really what you're looking at is that top left, you're typing in that crimp spec. So you crimp it, take that average hose wall thickness, your final crimp OD has got to be within tolerance, plus or minus 10 thousandths. And then once you did that homework and you checked it out and you're within tolerance, you got a 4-to-1 safety factor rated assembly, proven by us. You can show the customer your process. A little side note as well that I've actually been taught from some of my customers is when you're measuring your hose wall average, take a Sharpie and below where the ferrule or sleeve would end, write your crimp specs. So you're going to measure all of your hoses up, write your crimp spec down, and then all you've got to do is go to the crimper, look, enter in your crimp spec, and away you go. Why is that important? Because you're going to add this to your safety procedures in assembly, but salespeople can go to the customer and explain what is going on. And I'm going to tackle some objections here in a little bit, but the biggest thing is going to be, yeah, I get it crimped from the guy I already buy it from. Why do I care about you? Well, once you finally get in the door with that, it's showing that you're taking the extra steps to prove out your system, whereas they may not have as sturdy of a process, an assembly process, as you do, and it's a good way to differentiate. So here's the proven performance. So this is the hose that we just crimped. So you see at the top left, it's a 250 PSI assembly. We use the Campbell Cobra 3-inch 3/16 stainless steel. We had the 300 344. We didn't have to jump up to the 348, but we would have crimped to that 0.305 crimp spec had we not. We tested it out, and this was a crazy successful test. The hose went almost 5 times working pressure, but again, the hose failed before our Campbell Cobra failed. Our Campbell Cobra had a safety rating of 8.19 to 1 safety factor. That's just an insanely well-performed test. We've got Rebecca next week going to be doing some Campbell Cobra versus standard Cobra webinars. I really encourage you to sign up for that. The cam and groove market, I mean, it is obviously commoditized. So any bit extra information that you can do to succeed with this, to me, obviously, I'm a sales rep for Campbell Fittings, but why in the world would anybody not use the Campbell Cobra? It's perfectly priced up against the competition. It obviously performs, if not better than any of the other cam locks out there, alongside, Instalock. It's a great product, and again, it's all backed up by Crimpnology. Another good question that I get a lot is, hey, can I crimp lay flat hose? Generally banded, but yes, you can. The only extra step is that you take the average fitting diameter measurement. So you take your calipers and you measure the largest bump on the shank, and you get your average between a couple of those measurements. Let's just say 2 measurements. And then you use that green column there, the first column, and that's going to give you your measurement to base this off of. And then you take your hose wall average just like you would with any other hose. It's obviously much thinner, but that top row here is going to be your lay flat average hose wall thickness. You got this added just 1 extra step in the first column, and then you use the chart just like you would with the others. Measurable, repeatable performance. That's what we just did. We created assembly that is backed by engineered test reports. You got the safest assembly possible. You just got to trust the process, trust the system. And it's time for another poll. All right. Your final crimp diameter must be within plus or minus this number. Please give me 100% on this. Ooh, so close. We got a couple more seconds here. Good engagement. Thank you, everyone. All right, we got the majority of people voting. Good work. 10 thousandths plus or minus 0.010. You got to be within that range, and then the magic happens. Good work. Now for something completely different. I think this reference is probably out of my time range, but I do like Monty Python. I want to change it up. Oh, look at this guy. We all know this guy. There actually might be a couple of you lurking in this webinar today, some of you purchasing people. I don't mean any disrespect, but we got a tough battle when we're up against you. But I'm here to take you down today. A hose is a hose is a hose. I can get the same thing but cheaper from wherever. We don't have any problems. All my sales representatives, all my customer service reps, everybody hears this all the time. They just want to commoditize us. That's all they want to do. So with the backing of Crimpnology, you got some tools in that. But I'm going to take down these specific objections here right now. Hopefully a couple of these might be a newer thought. My favorite one as of late has been kind of reframing the end user thought on how they look at industrial hose. So I can get the same thing but cheaper, right? So they're looking at this crimped industrial hose and they're thinking, okay, I'm going to go to 4, 5, 6 distributors and say, hey, get me a crimped whatever hose. And then they're going to price it up. So reframe their thinking. A pretty good tactic I've seen my customers do is set up their customers with hydraulic crimpers. I think it helps you, get in there more often. It solidifies your presence there. You might do some VMI, I don't know. But it's a good tactic. You get them a hydraulic crimper and you're kind of in there. You got some business and a reason to go. Now I say, hey, why wouldn't you set up your customer with an industrial crimper? I'm not saying that it never happens, but you know it's a headache when you do have it happen if anyone's gone down that route. But let's just say the majority of the time, you're not setting up your customer with an industrial crimper. Why? Why are you not doing that? Well, it's because of all of the painstaking process that goes into crimping an industrial hose correctly to make sure that it works. All the assembly people must be, freaking out when they try and set a customer up all the time with an industrial crimper. I mean, it's a full-time job. You people make hose assemblies and you do it well. Try and communicate the fact that you're taking the extra time to do it correctly and communicate that to your customer. If they want to lump you in and say that this is just a commoditized product, why wouldn't you show them, the performance results of your process versus maybe a lesser hose, or implore them to also vet out the other people that they're giving this bid to also provide them with this information. If you're tracking your crimp process, and now there's cool Bluetooth crimpers out there that do it for you, but I'm sure most of you have some sort of safety procedure. But if you're logging your crimps and there's an issue, you're covered. So I like that one. I think it's a good way to spin it on them. They just want to make it a hose is a hose is a hose. I'm just going to shop this around. By really being able to differentiate yourself with not just the testing, but the way that it's put together and how you guys do it differently versus your competition, I think there's still a lot of value to that. And it's really the most important now since, you got, some competitors maybe, passing off their own process or, not having a true system, but it all looks the same unless we communicate that down to the end user. And same to the right here, the proven hose performance. I mean, like I said, this process works on all hoses. That's the beauty of the hose wall average and using our chart. But for a sales technique, we're more than happy to test something for you in order to get the business. Again, it's going not just, hey, take my word for it. It's a third party stepping in and saying, no, this stuff works, and here's how well it works. And then you tie that in with your assembly process and you got a beautiful thing. Here's some impressionable pictures. Like I said, I'm a visual learner. I want you guys to take away 2 things from today. But accidents happen. They happen. So you have that purchasing person, you got to go talk to who Trevor Klutz would probably talk to in the safety department. You got to get to the engineers. You got to get to even just the people using the product. They don't want it to fail. Purchasing people might not necessarily be looking at it. They've been trained to it's their job to lower price. Well, I got a good quote coming up that tackles that price question in a second from Trevor Klutz. But really, I mean, can you afford a failure? All the flashbacks of hose failures past, you can't do it. Even if you have the best relationship with your customer, how many times are they going to forgive you for a hose that won't work? Maybe once, twice if you're lucky. You don't want to go down that trial and error route with them. They're going to start losing confidence in you, and they're going to remember, oh, here comes the sales rep of that hose that shut me down, or that hose that God forbid hurt somebody. You can't afford the failures, and you just need to strive to talk to the correct people. We all need to talk to the right people to make sure that they're caring about the right stuff. Because if you think safety is expensive, try an accident. Who said it? My man, Trevor Klutz. Story of the day. If you think safety is expensive, try an accident. I don't know how much you want to pepper that into your conversations, probably with the ones that you can kind of joke around with, but it's true. It's true. You can't afford these failures, and that's everything that we're trying to help you out with Crimpnology. We want to help you differentiate. You've got to trust the system, stress that importance of performance, and you don't want to be like all the other ones. You get lumped in. They want to commoditize the heck out of all this stuff, and we give the tools to really differentiate you. And I'm going to plug in some of these webinars coming up. I mean, this was like the foundation of what we're doing, right? So, you got to get that hose to work. You can sell your face off, but out in the field, if your hose is failing because you're not assembling it correctly, they're not really going to care what you have to say. So here we are. We have the foundation of Crimpnology, but we've got a ton of other really great webinars coming up. Like I said, later today, we got combination nipples versus Crimpnology nipples, how to select the ferrules and sleeves. We've got even extending into our ideal group. Some of the people on this call are pretty Campbell heavy people. So broadening our horizons to the ZSI Foster line, the ideal line, we've got great stuff over there, really trying to make us more of a one-stop shop. And, not to mention, we're right in line with them on innovation as well. And I'd encourage you to join those presentations to learn a bit more. But what did we learn today? Crimpnology is the foundation of our success together. We offer the tools to help you succeed. Safety, just bring up safety. It is key. We can't afford those failures out there. Performance, performance, performance. Not just about quality. It's not I said it's good. It's not just trust me. It's here it is, hard, concrete, factual evidence. It's just a great way to go to market. So again, last little blast in the face here. Measurable, repeatable performance. As long as you're within tolerance, we're standing behind these assemblies. It's what we do best. And yeah, so I'm going to open it up to questions here. Chris will read them off to me. I've got a couple I saw come through, but yeah, thanks for listening, everyone. Okay.
I'm
Chris,
off,
you
Tommy.
muted? What's that?
I'm off, man.
You're off.
Oh, I'm on. Never mind.
What? All right, I see the questions here. We're good. But yeah, go for it.
Okay, so we had one question about, can you explain on the instruction sheet on 1C was bend in the helical wires.
Yes. So yeah, so for some hoses you're gonna have electrical continuity, right? I mean, but for like what you're probably thinking of is like maybe like a PVC hose or just even like a chem hose. You're going to cut that hose and the wires are going to be there. So you want to push that down inside the ID of the hose before you crimp, so you don't have any, of that hard wire biting into the ferrule and disrupting the crimp.
Okay, and there was another question about safety factor versus a burst or failure pressure rating. I think it's referring to some of the newer hoses from, we'll say, smaller companies, or in the large bore lay flat world. They use the burst pressure, the failure pressure, rather than the 4-to-1 safety factor. And was wondering if you could address that difference.
They use the burst pressure, so like the pressure rating on the hose is their burst pressure.
No, they'll use let's say it's a 250-pound hose, and so this, rather than a 4-to-1 safety factor, they'll say that the burst pressure rating is 400 psi. So the factor itself will not equal. They're not giving you a safety factor. They're giving you a failure pressure, which generally is lower than the 4-to-1. So it's a difference in terms of the design, and so the design factor, which is what is referred to or can be referred to, would be different than a 4-to-1. Because remember, the 4-to-1 is an RMA safety factor, but it's not a requirement.
Right. So the new hoses are showing just the failure.
Oh. Well, some hoses. I mean, if it's a Continental or Gates or Parker, they stick with the 4-to-1 safety factor.
I guess I don't know if we would just divide it by 4 to get our working pressure, but maybe doing tests on some of those to see how that proves out wouldn't be the worst thing for us.
But I think that's.
I don't know. I'm not aware. I haven't seen that.
Yeah, it's probably, you see it sometimes. If you calculate it out, it'd be essentially a safety factor of 1.8 or something along those lines. but it's normally the thinner wall, like large bore lay flat oil field type stuff, or import hoses that probably can't meet the 4-to-1. So from a sales perspective, certainly from the hose perspective, if you're using it, you need to let everybody know that that's the failure pressure. But it is just a different thought process from a hose manufacturer standpoint.
Good to know. Good question. All right.
And I'm kicked off your screen, so I can't see if there was another question.
Yeah, I caught a few. Well, actually, one was on the helical wire. Somebody was asking how to decide between a ferrule and sleeve. That's based off of the stamp data. Again, like all the pressure ratings we have are 4-to-1. So let's take like a standard Cobra versus the Campbell Cobra test that we saw today. Standard Cobra is still going to be pressure rated to say 150 at 2-inch. We've tested that 4-to-1, whereas a Campbell Cobra is going to be 250 psi tested 4-to-1. So it's really just depending on what pressure that customer needs. You need to test your product on every hose. No, you do not need to test on every hose. You take the hose wall average, and it'll work. That's the beauty of the system. And let's see. Sorry, it's hard to read these.
Here, I got them for you, Tommy.
There you go. All right.
Yeah, could you go over using an alternate ferrule for crimping again? In other words, how many sizes can you go up?
Right. So, hey, maybe I'm going to click back here. All right. So, an alternate ferrule, like this is the biggest thing. So like if say this question was coming from a company that's not set up with Crimpnology yet, stocking the correct ferrules and sleeves is the first hurdle. So what I generally do is get a hose list. You take the hose spec from your hose manufacturer's site. You surmise their hose wall average based off of I might send that as a follow-up, but basically just like cut their OD minus ID in half to get your hose wall average. That's going to give you a fake crimp spec, guide you towards what ferrule to choose. And then I'd load you up with, like, say 3 sizes. Let's go FPS 300, 336, 344, and a 348. So you have a kind of range. Now, if you run out of the 344 in this instance and had a hose wall average of 0.305, and you only have a 348, you bump up to that size. It's going to be a bigger ferrule, so you have extra space, but you remain crimping to your measured average here. You do not go and jump to the next nearest crimp spec because you went to the higher ferrule or sleeve. You stay on the crimp spec that you measured your hose wall to. And that's really the main crux behind that. Obviously, if you have a 340 and you measure to a 344, you might struggle to get that 340 over the hose wall. It might be too thick, so that would be the issue. But you can jump up a size. I say you can jump up 2 sizes, but I have talked to Randy, our head engineer, and that's not necessarily the best method, basically because you're gonna have to jog that crimper down, because if you're moving all that metal, you're gonna have high ridges on that ferrule. It's not gonna be smooth. That's sort of a side note, but yeah, sorry to execute that question. Yeah, you can move up 1 ferrule size, but you stay crimping to the size that you measured to.
And there's another question, just a clarification for the bending of the helical wire inside the hose. Is that to touch the hose stem for static or conductivity and static charge?
Yeah, but if it was on the outside of the hose, it would probably bite into, the outside. But yes, static charges, the helical wire will ground you, but it won't disrupt the inside of the crimp like that. Obviously, you don't want like a huge wire biting down like a couple inches. You want that to be a small wire, but yeah, take your, whatever you got, bite it in. Pliers.
Okay, well, there's another one. Nope, I think that's it, Tommy, unless you got a couple.
All right, everybody. Thank you for sticking around, and yeah, sign up for some more of these. These have been great. I appreciate everybody, joining us. It's the best we can do in this time, but hopefully we'll be out face to face here soon, and I'll be sending a follow-up. I'd love to meet up with anybody that has more questions, or we can do another crimp clinic in person. Obviously, is a lot better. But yeah, again, thanks for everything.